Hello, hello. Is this thing on? Houston, can you hear me? Type 486 in the chat if you can hear me. Or I'll just figure out if it's working here in a second. Boop, boop, ba-doo. How is everyone doing? Good, I hope. Okay, I think we are working. Nice, all right. Today, I want to tackle the rest of replacing the caps on this thing. I'm just about done with it. But there's some annoying through-hole pins that I need to clean up. And then put the new caps on, which shouldn't be too bad, provided I get everything all cleaned up properly. Oh, and let me get the code going. Let me get the code going for the breadboard. I want to test that. I kind of want to try to add the Twitch implementation. I might do that later. Boop, 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 boop. Twitch's API for listening is, or for just like listening to chat, is kind of annoying compared to this other library that I was using. Hello? Is this thing on? Oh, I unplugged the screen. Dadoy! Wow. Okay. All right, let me get the software running for this again. Where's my thing of resistors? Oops. Wow, thing is bright. There we go. And then we'll stick this back in there. There. The code is running, so... Wow, hello. Camera sucks. Bruh. There we go. And let's send a command. Okay, now I want to send connect 21 to top rail, and then hopefully everything's working fine. Or I guess not. Guess nothing is working fine. Oops. Helps if I include the command. Oh, that's why. Because I'm not listening on the right video ID. That's funny. Okay. I'm just setting up some code over here. Get running. So I can start taking check commands. Okay. Let's try this again. Did that do it or no? Hello? Guess not. Okay. Oh, it is getting it. It's just not sending it to the device, I don't think. Let's try this. We will unplug, plug it back in, rerun our code, and then I'm going to send the command again. And that should do it. Yeah, there we go. Cool. All right, nice. Okay, cool. That is working now. What is the voltage on that top rail? .5 volts. Okay. 3.9. All right, we'll set it at 4.2 volts because that's what this is a 555 timer. That's what that thing wants. So let's see. There we go. And I think everything should be working now. Cool. Alright, I think I got these three holes cleared. Just gonna test them real quick. I just use a shitty piece of wire. Those are not cleared. Those are cleared. That one isn't. Okay, so we've got three that we need to do some work on. Okay. That's what, this one? Yeah, that one. And then these two? Yeah. Okay. Okie dokie. Yeah, let's try this again. Alright, I think that's all of them. Nice, okay. I need a iron holder. I've got one. It needs a bearing. So let me flip this over. We'll refer to our drawing from yesterday on where we need to stick all these capacitors. All right, so let's start with this one. This is a 1 farad or 1 microfarad 50 volt, which is supposed to go to the bottom right. These two right here. So, and all the negative leads are facing to the right. So this one goes right here, like so. We'll need another one of those. It's probably this one, right? Yep, there's another 150. All right, let's get those two on there. We'll double check. That's 150. That's a 150. And then on the, yep, okay, cool. I've gone ahead and splayed the legs out a little bit so that we can kind of hold it in place. So go ahead and get those soldered down. All right. That should do the trick for those. I don't know if you can see those very well, but they're on there. Okay, I'm just going to trim these off really quick. Before I go and get to that next section, or next set. Ow! Burned myself. Let's see, clip these off. And then we'll put on our next, well, we have 3 more capacitors. Not too many. Is it really soldering if you don't burn yourself once in a while? Okay. I actually need a legit iron holder. Alright, cool. Those are on there. And let's go ahead and get the next couple. So we've got, got a 0.33 10 volt, which I believe is going to be this one. No, that's the 100. Here we go, 3316 volt. We've got 2 of those. Yeah, 2 of those. Okay. So this one goes with the negative pin to the right in here. Okay. And then the other one, 3316, is at the top right. We'll do that one as well. Okay. And we've got those splayed as well. Go ahead and flip this board over and kiss these with a little solder. Just pick up a little of that extra solder. I think we're good on that one. And then I think we got one last capacitor. This one is the 100 microfarad 10 volt, but we have a 100 microfarad 16 volt, so that should be good. Alright. I think that does the trick. Just make sure that all these are well soldered. I think they are. I think we're good. Now to deal with the massive buttload of flux that's on the board. So let me get this stuff out of the way. And I'll go get my cleaning kit. We can clean this shit up. Alright, be right back. 1 second. Okie dokie. Oh, should probably clip these off first, huh? Alright. Man, I got flux everywhere on this thing. Maybe I used too much flux. I also think there was already a lot of flux on the board from when it was assembled, or maybe worked on the last time. I don't know if this thing was worked on prior to me getting to it. I think this may have been wave soldered. I don't know. That might be why there's like a ton of flux on it or something, but who knows? I'll clean it off and we'll spin it up and see if it works. I think that's probably clean enough. Oh yeah, that's definitely like original flux on this thing. I just ended up cleaning a bunch off. You can see on the board where it's like still kind of reflective, and then there's a section where it's kind of matte. Yeah, so I've cleaned it up enough. I think it's probably fine. We'll let it dry for a little bit. I gotta clean my fingers off. Jeez. Okay. Fingers are not as sticky now. Hey, love rar. I see you're trying to mess with the breadboard. There's a whole row of lights down at the bottom left that you can mess with. You just got to connect them to ground and to the top rail. Yeah, let's see if I can get one going through the chat. So that whole bottom row starts at 31 and ends at 60. So we can do connect. I think it was ground on the left, positive on the right. So let's do ground to 31. And then let's connect the top rail. Top rail to 32. And that should turn on the light. Or maybe it's the other way around. It could be backwards. All right, I need to disconnect. Hey, there we go. Oh, rip. There we go. Oh. Now all I have to do is connect grounds to the bottom, or to the even numbers of those, and the light should turn on. Wonder if this thing is dry enough to test. I bet you it is. It's probably fine. These guys are caked in flux. down. Trying to collect all these before they end up in your feet. They call them legs because that's where they're gonna stab you. Oh, did I miss one? Probably. Okay, let's, I kind of want to assemble this, put it back together, and see if it's working. At least we can, we'll reassemble it to the point to where we can plug it in and see if it works. Oh my god, is that flux too? Holy shit. No way. Oh my god, I got flux everywhere. Look at that. Okie dokie. Alright, and the positive was over here, negative was over here. So, let's go ahead and get this connected. Actually, I want to double check that every freaking time. I can't remember where that goes. Get the continuity test going. And I think... yeah, negative is this one right here. Wait, no? Okay. Alright. That means positive is over here. Oh my god, these clips are awful. It's not the clips that are bad, it's the sleeve on it. The sleeve on it is so slick. Okay, so that should be 6 volts. Let's see if it fires up or catches fire. Not a whole lot of nothing. Okay. Worst connector covers ever. Oh, whatever. Okay, so it's still not working. It just doesn't seem like we're getting power to any of the components that do anything. I'm not seeing any wattage on the power supply, nor any amperage, so there's no current flowing through. Whatever shall the problem be? Okay. Well, then let's start probing it again, I guess. Oh, come on. I give up again on that. Oh, what? Now it's pulling something? .39 amps? Nothing? I'm confused. I don't know. Let's try... Oh, where's that schematic that I had? The block diagram or whatever, pinout. This boy. That's interesting. So we've got segment driver sections right here. H, G, F, E, D, C, B, and A. And on the board, I've got some similar markings right here. We've got P, G, F, E, D, C, B, A, H. So maybe we can check the segment drivers for voltage and see what those are getting. So how the fuck do we do that? I don't know what those are supposed to be voltage-wise. Maybe the site will tell me. So I'm only getting a couple volts, like 0.02 volts out of some of the segment drivers. Is this fuse bad? No. Because if the fuse is bad, then I wouldn't be getting anything on the board. Also, it looks fine. Okay, so what else could be wrong with it? VDD is supposed to be negative voltage. That's pin 14. That's this one right here, I believe. Let's check that. Yep, 5.8. Steadily dropping. For whatever reason, probably because I'm sinking it to ground. I don't know. Okay, and then opposite of that is VGG. That's also negative voltage. We're right here. Okay. Common voltage is right up here. 6 volts. So we're getting 6 volts to the chip. Let's try segment driver H, pin 23, which is 1, 2, 3, 4, 5, 6 pins in on this side. So 1, 2, 3, 4, 5, 6. I've got 6 volts going out to that. And segment driver H. Yeah, so then let's check, H to ground looks good. Maybe there's something wrong with the actual, segment board. Because it looks like it's on, right? Let's check the clock input. It's gonna be this top left pin right here. Right, if I do a calculation on it. If I clear, right, and I do 1337 times 1337. Nothing. No wattage, no nothing. Okay. Oops. Hmm. I mean, these all look particularly fine. It's just got some nasty flux all over it. I don't think that's really going to cause any issues. What do these VFDs actually take to operate? I'm guessing it's less than 6 volts, or 6 volts, right? Because we could try to power them individually, just to test and see if they work, like through the board. Can we take that? We can take them out of the housing, right? I think. I don't know. I don't want to take apart this housing and bodge it up. It would be nice to test these. I have no idea how they work. But I guess that's the start to fixing or testing anything, right? Is not knowing how it works. In the wise words of Jake the dog. The first step at being good at something is being bad at something. Okay, let's check. I wonder if we can test, what is this thing? I feel like this is like the transformer for it, right? This right here, CT850. Yo, what up, Purple Really? You can control the breadboard. I was setting up some pins on the breadboard through some chat commands. Is it CT850? Okay. Yeah, I'm not sure what this part is, but I think it is. I think it's the transformer for the low VFDs. Yeah, the thing in the top left corner. Here, let me put the camera on it for you. Yeah, you see how it's got some rows at the top and rows at the in a row at the bottom with some numbers on it. Those are like the columns, and you can connect those with the connect command. You can disconnect them with the disconnect command. Yes, if you want, I've got a resistor hooked up to pin 21 at the top right of the board. If you connect that to the top rail, it should turn on the LED. Yep, I'm not entirely sure what this part is. Where is it? I saw somebody had... There we go. Old photos of it. Discrete transistors are used to drive the display. The switching power supply located on the main electronics board is rather complex. Alright, so let's learn a little bit about these VFDs, and then maybe figure out what voltage they're supposed to be, and then we can probe the board for that voltage. But you'll know if the LED is on or off. Oh, stream delay is pretty high. Breadboard's got LEDs underneath it, like in each of the pins. Here, got the code running. We can see. Oh, I guess it broke. That's probably why it's not working. My bad. Yeah, it helps if the code doesn't break. Yeah, so let's see. You can control the LEDs that are under it if you make a connection. So you can, like, say connect 13 to 14, and it'll make a color under it. So do top rail to 21, and that should connect and turn on the LED. Everything works. Hey, there we go. And yeah, and there's some at the bottom left too, so if you want, you can mess with those. Hopefully the code doesn't break. I don't know why it broke that time. It's kind of zoomed in. This right here on the board is a little 555 timer, so that gives you a scale. They're normal through-hole components. Typical voltage of such a small display is only 25 volts. The larger ones need about 30 to 35 volts at a current of 3.85 milliamps. That's not specifically the same VFDs that I'm working with, but I think that's a pretty good starting point, maybe. I guess we could try plugging it in and probe the board a little bit more. You want to buy electronics, but your only source is Temu? I don't know. I can't really say because I haven't really used Temu a lot, but some people have good luck with it, some people don't. I think it's just iffy. I would say do eBay if you have access to eBay, but if you've only got Temu, then I would say that something's better than nothing. Wow, they came with bent pins? That's annoying. Hopefully you were able to bend them back and they were fine, right? I hope. Maybe I can plug this in, so we've got negative right here. Oops. Negative right there, and positive right here, and then we'll try probing this. Hopefully don't blow anything up. We're getting 0.01 volts. Not a whole lot, especially considering we get 6 from the main. And I doubt these VFDs run on such a low voltage. So maybe we need to figure out where on the board these VFD pins run from. Let's try some continuity testing. Oh yeah. I mean, if they work, they work. You might be getting knockoffs. I've heard that happens sometimes with like integrated circuits and chips and stuff, is that you get knockoffs. But if you're just testing around and like playing around and having fun, knockoffs aren't too big of a deal unless they cause confusion and issues. If you have issues with them, then that's problematic. But if they're just knockoffs, but they function the same, then I wouldn't be too worried about it. Yeah, none of these are going straight to ground. So it looks like all of these pins come from, like this bottom row of pins comes down to this thing right here, which I guess is some sort of capacitor. And then that runs over to the digit matrix thingies, whatever they're called. What is it? Segment drivers. And these are powered from these two pins? Like, what is that? There's a resistor right there. And then what does that go to? That goes to a transistor right there. And then from there, Goes in this, feeds this over here, this next row of transistors, or this next row of capacitor, or whatever that is. Yep. I'm not certain. I could probably, like, take some photos of it, both sides of the board, and then try to sketch it up in KiCad or something. Not necessarily building. I'm trying to fix this thing. It's an old vintage calculator from like the 70s. And it's got some vacuum fluorescent displays, which are pretty cool. So I want to get those working. Yeah, so it's pretty neat. It'd be cool to get it working, but if not, whatever. It wasn't super expensive, and it's got some cool parts in here. Let's see, it kind of goes like this. Yeah, so it'd be neat to get it working. Nada. She's dead. You got a knockoff, but it was better. That's funny. I mean, yeah, sometimes knockoffs are like that. Like I said, it's not really an issue unless it causes issues. Like, I've heard horror stories of people like trying to debug some sort of weird issue with the chip that they bought. It turns out it was a knockoff. And it's just giving them weird problems. Helps if I have it in the right mode. I got nothing coming into this. 0.01. Let's follow this backwards. That goes over into this. Which goes... Oh, that's the next one over. Okay. If we probe this coming out of here, 0.01, 01. Oh, see, now we've got almost 6 volts over to the VFD matrix or the segment drivers. Alright, how about if I do, let's clear this, a bunch of zeros, if that does anything to help us. Does this show up as more or less lit? Got 5 volts there, 5 volts there. And this is the connector that goes to the actual like VFD board. So it makes me wonder if the VFDs are even working. Because we're getting 5 volts to them. I don't know if that's supposed to be higher or not though. Imagine it's supposed to be higher. Yeah, I've got voltages coming out of it now, so I do not know what the deal is. Oh yeah, that's a fun idea, like turning normal electronics into IoT stuff. I've seen a couple write-ups of people doing that online, and it's always pretty fun. See, 1, 2, 3, 4, 5, 6, sixth pin. 1, 2, 3, 4, 5, sixth pin. Let's see if we get continuity anywhere over here. Might be on the back side. Nothing? I don't know if that actually proves anything or not. Let's see. 1, 2, 3, 4, 5, 6. This one right here. And we'll test it with the back side of this. Or we can test it. It's supposed to come over here to H. Right here. Right? 1, 2, 3, 4, 5, 6. I guess not. My assumption could be completely wrong. And there may only be a, No, let's see where that runs. This goes to this transistor right here. Bridge is right here with this resistor. Oh, that's confusing. Nice. It is definitely not that early in the morning for me. Sometimes it is, though. I don't know if that's a good thing or a bad thing for you. I don't know if you've got work to do or something tomorrow. Yeah, so I think this is the ground pin. Maybe. Because it kind of hits these all throughout this whole back plane right here. Yeah, so every third pin is a connection with this right here, so I think that's our ground. That's the one on... One, two, three, four, five, six, 7. It's the 7th pin in from over here. So 1, 2, 3, 4, 5, 6, 7. This dude right here. These... Is there a ground connection up here or something? Nope. Yeah, so it's definitely that pin, this one right here. But I don't know where this goes. Or where it's supposed to go. I guess it goes to this transistor right here. This is kind of like a whole row of them. They're all connected. Their center pins are all connected. Is that the collector pin? I don't know. Not too familiar. Hey, what's up, GT Fresh? She, by the way. But yeah, it's a vintage calculator from the 70s, and it's got some VFDs on it. I'm trying to see if I can get it working, but currently I'm not having any luck. I went through and I replaced all the capacitors on it, because usually that's something that's fucked up. With the exception of like these ceramic ones. Just all the electrolytic capacitors, I went and swapped on them. And I still got no display on it. So not much has changed. And I'm not too sure where to go from here. I was probing around, and I'm getting 6 volts across most of the board, so I think it's working generally. I just don't know why the signal or why the voltage isn't making it to the actual VFD board. Or if it is or not. I don't know. I guess I could try to get a probe on it with the voltage. So this is our negative. And this is our positive. This may not work because I don't have the power switch going. Sure, yeah. Thanks for stopping by, Purple. Alright, just to double check, we've got our voltage pin right here. Let's check that. Oop, not continuity. Alright, so we've got 6 volts going to the chip. Well, roughly 6 volts. 5.8. So let's check one of these going out to one of the segment drivers. So 16, which is this one. This is segment driver A, which goes to, I think we've got A right over here. They've got some silk screening. I say silk screening, but it's solder screening. Let's check this going to here. No. Yeah, I'm not too sure. Yeah, I might throw this into KiCad. Like, take some photos of it and try to get the schematic down in KiCad and try to figure out where this is failing. Because right now everything on the board looks good. I don't know enough about this chip though. You know what it's supposed to be doing. And I feel like I should be getting more than 6 volts coming out of this dude. I think I should get more than 6 volts out of this dude. I think this is the transformer that's supposed to drive the voltage high for the VFDs to run. But I'm not getting what I would think I should get out of that. But I also don't know the pin layout of it either. VF2 YLPRD. Maybe that's what it is. I'll look that up. Nothing. What about YLPRD? Oh, VF2 is the, that's the array for that. Okay, that's not actually a part number. YLPRD. YLPRD. Did that come up with anything? Nope. It thinks I misspelled Lord. Good Lord. Okay. Let's find out more about these tubes and see what voltage they're supposed to be ran at. Or we can try to take them out of their little enclosure. Maybe I can test them individually. I could try that. If I figure out what the pinout is on them, I can try testing them individually and see if they work. Maybe they're just bad. I don't know. No. Where's the list that I found? I think this is where I saw it. Yeah. So we've got these first generation VFD tubes with 8 segment digits. Typically, each digit is made of 7 anodes arranged in the typical 7-segment pattern so that all numbers 0 through 9 can be generated. Some early VFD displays have 8-segment digits, as shown below. An extra mini segment given a better looking 4. Oh, gotcha. Do I have those? I don't think I have those. Oh, I do. Okay. Let's see. See over to the right of the VFD. Oh, my broken ass spudger. To the right of the VFD, there's like this little notch that's coming off the 7 segment. That's what it's talking about. So we have 8 segments on this thing, which I think, given the number of pins over here, we've got 4 pins right here, 4 pins on the other side, and then a whole 2 back here. So I think these first 4 might be the actual pins? I don't know. Let's see. See if we can find out what the pin out of these is. Sharp Digitrons. Hey, what's up, Tibet? How are you doing? Between the anode and the cathode is an open grid. Applying a negative voltage to the grid switches the digit off completely. Part of me wonders if the chip is bad. The actual IC. I don't know. I do kind of want to try and drive one of these. I don't know what the voltage is, though. I'm doing pretty good. I'm trying to fix a vintage calculator with some vacuum fluorescent display tubes. Because it's cool, and I want it to work. I mean, look at the design of this thing. Isn't that wild? Ain't nobody making hardware that looks like this nowadays. Yeah, I originally bought it because I wanted the tubes out of it, just to have some tubes to mess around with. But then I saw it and I was like, no, I need to get this thing working. It's way too cool to not have working. Oops. Oh wait. Alright, yeah, so this is kind of what I'm working with. This is the chip on the inside. And I've tested all of the pins, I guess? The segment drivers, at least. I've tested those. And I've tested the common voltage, key matrix input, clock input. Actually, I haven't tested the clock input. That one was probably important, right? What is the clock signal? What's generating the clock signal on this thing? Is it this giant array of transistors, or no? I guess I could plug it in and test it with the clock signal. Or test the clock signal. That's going to be this one up here. And I believe it's coming out over to here. Might be better to get the scope on it. If it's a clock signal, I want to see it fluctuate. So maybe I'll try that. Let's do. It's going to be tricky because I'm not going to be able to have the pins available while I have it flipped over. I believe this is my clock pin, though. So Okay. And let me see. Let's see if we can get the clock signal on this thing. Let's see if we can find it. It is going to be negative right here. And the positive over here. I think it should be giving me something. Oh, is it because it's not turned on? Good doy. That might be it. Alright, so this should be a clock signal. Yo, Patrick. Eat Patrick. How do? Oh man, I'm such a fucking idiot. It's because the damn thing isn't on. Oh my god. Bruh. Why don't you guys tell me next time when I'm not probing anything? Oh my god. It's all y'all. It's y'all's fault. Okay, let's see if we can actually get a clock signal or something. I think this one should be it. No? Is it this one? Oops. Alright, that's our voltage pin, and this is our clock pin, this one. I'm not getting anything from the clock pin. Maybe... No? Nothing. Where was the 6 volts that I was seeing earlier? I could have swore with the multimeter. Unless I had that on the wrong setting too, right? Yeah, so 6 volts right there. Is the calculator important? No, it's not. It's just cool. Is it not on now? Pretty sure that's off. Let's see. So getting 6 volts there. Oh, 7 volts there. So wait, is the power switch backwards? 6 volts there, 6 volts there. And then let's check the driver circuits. 6.5, 1.9. Hmm. 7 volts on this pin. 7 volts on that one. I bet we have a clock signal now. We check, what is it, this one? That should be our... Oops. I'm getting anything from the purported clock pin or the CK clock input. So, I mean, I'm getting 7 volts. You would think the CK pin over here, so you'd think that this CK would kind of be like going back and forth, right? The clock input. But it's just kind of there at 7 volts. That's this dude right here. I'm not sure where on this board the clock signal is actually being generated either. Yeah, the old handheld football games. Those things are fun. The Tecmo football games. Wow, okay, so I did have the switch backwards in my mind. Bring it into the off, that's the off position, but this is actually the on position. I think? Oh no, I'm not getting anything from the... Oh, there we go. Yeah, so we're getting amperage. We're getting some current through the power supply, so I think it is on. But still no display. We've got 7 volts going to the actual VFDs. These are the pins headed to the VFDs right here. Some of them are at 7 volts, which I believe is what it's supposed to be. At least higher than 6. Maybe what we can do is we can try, I don't want to blow the VFDs up, though. Maybe we can try running them, or driving them ourselves. I don't know what voltage they're supposed to run at, though. This is what we've got. These little dudes right here. Oops. Helps if I have the keyboard on the right system. Tube store. No, that's not what I want. Pneumatrons. Nope. It'd be nice if I knew exactly what model it was, but it doesn't tell me like a model number. Alright, well, I think I'm going to take a break for a few minutes. I'm going to give you guys a nice view of the breadboard. You guys can control this while I'm AFK. Ah! Focus! Focus, you fuck! Hello? Camera sucks. Alright, I'm gonna take a break. I will be back in probably about 10 minutes. Grab a snack. And we will keep poking at this thing. If you guys want to know how the breadboard works, check out the description. There should be a link to the GitHub repo where I've posted the code, and then also the syntax is basically all the MicroPython API for the jumperless breadboard, but you prefix it with an exclamation point. There are certain commands that aren't available, so if it doesn't run them, you're shit out of luck. Hello, hello. Sorry, Patrick. The code exploded as you ran your commands, and so they didn't do anything. Rip. I don't know why my code keeps breaking. It's probably because I wrote it. That's probably why it breaks. Yeah, and this thing is this is a button. I'm just gonna take that out. I don't need a button on there. What's the button for? I did have a little speaker though, which is kind of fun. Here, I'll put some new stuff on there for you. This one is going to go from 1 to 2. Also, positive connections, with the exception of something like this. Actually, I could probably flip this around. I should. I think positive connections should always be on the right-hand side of the device. If they're positive. Alright, let's try this. What is that? I'll work with top rail. I can't remember. Yeah, there we go. Alright, here, I'm going to flip this around. And that way the positive connections are all to the right. And then if we do connect 31 and D, and then we connect 32, right, top rail. There we go. Yeah, the delay is pretty long. Should figure that out. Be nice if it focused so that you could actually see the numbers. But it probably won't. Okay, where do I want to go to figure out how this damn thing works? Or how it's not working? Let's see what the power connectors button is. Right now it's on. Okay, so it looks like it's these bottom leftmost pins, or bottom rightmost, which is going to be these. These two right here. Reorient this. Alright, I guess we could bridge these two pins, and that would, put power into the board. Or at least turn it on. Let's get a clip for that. I don't think I have a suitable device to bridge those with. Actually, I can do it. I can do it with some grabby things. I think that'll work. The jumper. A yumper. Get our two yumper connectors. And go grabby grabby. Right there, and right there. That should be it, right? I think so, unless they're doing something fucky with it. I believe that is it. Alright. Pulling 0.039 amps. Take that off, Yay! Okay, so that is functioning as a power connector. Or power switch, at least. Okay. I want to probe the lock pin, right? That's what I want. Or I could mess with that one again and see what comes up. I mean, it's high. I do not think I can get down there and get just the lock pin. Oh, oh, no, there we go. Wow, camera just went out of focus. Good job. Hello? Hello, hello, camera. It's just like, no. No, I don't want to be in focus anymore. Wow. I don't know what to look for. Oh, I can probe the bottom side of the VFDs. See if, those actually have voltage to them. Now that I've got it on and upside down. I still don't really need the clock source on there until I'm, like, chasing that down, I guess. Uh... 7 volts, 7 volts. Yeah, maybe that's just not actually, getting as high voltage as necessary to run the tubes. I still don't know what the voltage required to run those tubes is supposed to be. um... You know? Would be nice to know the voltage. Typical voltage of such a small display is only 25 volts. Oh yeah, if we're getting 7, that is definitely not enough. So maybe I could try driving it at 25 volts myself, like manually. At a current of 3.85 milliamps. Yeah, this is what I'm going off of. Is that enough to run some voltage through it and maybe pop one of the VFDs? I guess so. I don't know. Why not? Worst case scenario, I can pull the VFDs out, right? Use them in something else. Let's see which pin has the high voltage and which one doesn't. So there's supposed to be 8 segments, which means at least 8 anode pins and 1 cathode pin, I think. I think these have 1, 2, 3, 4, 5. They have like 10. Oh, they have dots, so... No? I don't know. So these center pins on each of the digits, each of the tubes is like about 7 volts. Top center pin. What about the bottom center pin? That is also 7 volts. What about this little pad right there? 7 volts. Is that connected to anything as well? No. Yeah, that's what I was thinking. It's probably like the transformer that's gone bad on it or something. Because we should be seeing much higher voltages on the board over here to get the VFD powered on and working. Seven volts. Oops. I wonder how these are wired. Are they wired in like a clockwise fashion or something? Here, I'll show you the board. Disconnect my power switch. So, ooh, that's kind of warm. No? Imagining things? Okay, whatever. So these tubes, I'll get you in closer. It'll focus. So there's I might just use these, flip onto them. but there's kind of like a grid layout, or at least a circle of pins, and then there's like a little center pin right here, or center connection. There's 1, 2, 3, 4, 5, 6, 7, 8. And then 9, I guess, is this one right here, which has less pins. So I think each of these corresponds to a segment. And then one of these is a ground pin somewhere. Potentially. I don't know. I want to clip some stuff to it, maybe run some voltage through it and see what happens. So let's turn this off. So then I guess if the problem is that the VFDs aren't getting driven high enough, they're not getting enough voltage, then I probably need to replace the voltage driver, which I think is this dude right here. It's kind of transformer shaped, right? And on it, it's got some markings that say YLPRD. Well, next to it. Okie dokie. I don't know if you can see this, but there's the legs underneath. So I think it might be not too bad to try and drive some of these. Let's try to find I guess a common ground. So there was this pin that I tested earlier. Oops. This one is, seems to be going off on like the top right pin of each tube. So that one, this one right here. And that corresponds with this pin right here, which goes to, that's the third one in, right? 1, 2, 3 from that middle gap. So 1, 2, 3 pins right there. Where does that go? I have no idea. Oh, that's right. Okay. That's going down to this capacitor. I think this is a capacitor right here. Ceramic capacitor. So that's getting juiced from that, from this right here. And that goes to here. Okay. I don't know what that tells me. All of those pins kind of go down to this capacitor right here, it seems. All of these lower pins. Oops. Knocked my connector off. So I'm just grabbing that that pin at the top right of the VFD of the tube, that one tube at the far right. And like I said, that was what, this one right here? Yeah, so that's beeping right there, which I believe comes down to right here. This whole capacitor, whatever this thing is. I don't know what that is. Maybe if I knew what this part was, I could probably troubleshoot this a little bit further than that. This is the driver matrix, though. So, like, on the actual pinout for this thing, these are, like, segment drivers. That's kind of this whole section over here. These are all the segment drivers. But this one's common with the rest of them, so I think that's, like, a common negative connection or something. Or is this what it is? Saying between the anode and the cathode is an open grid. Applying a negative voltage to the grid switches the digit off completely. So maybe that's what that is. Typically, each digit is made of 7 anodes arranged in the typical 7-segment pattern so that all numbers 0 through 9 can be generated. Some early VFD displays have 8-segment digits, with an extra mini-segment to give a better-looking 4. So that would be 8 anodes, right? And then on the back of our thing, we've got 1, 2, 3, 4, 5. Well, I don't know. It'd be easier if I could see all the way in there to see all the pins. But I'm thinking it's probably 10, right? Because there's also the dot? No, that's still only 9. Because you have 7 for the 7-segment display, 8 for the little tick mark, or the better 4, and then 9 for the dot. That's only 9 anodes. We have 5 right here. The markings on this has like an E and H next to it, so maybe that's like the E and H driver. So like over here, we have E, we have H. Save me, Instructables. Ah, but see, this one doesn't have that. Heater filament. Lit. Oh, here we go. Background in theory, fundamental VFD operating principles. We have cathode filaments, control grids, and illumination anodes. There's two different driving modes. There's multiplex drive and static drive. In a static display, each anode segment is individually connected to a lead pin, and a single grid covers all the display patterns in the VFD. This has the advantage that it only requires 10 to 15 volts DC to illuminate the display, and in some cases, illumination is possible using standard 12-volt CMOS logic. Is the major disadvantage is the need for more lead pins and IC drivers as the number of anode segments increases. So multiplex drive, let's see, each character has its own separate grid, which not only diffuses electrons from the filaments, but also controls the selection of the character position in a timeshare multiplexing cycle. The duty cycle on time of each character will determine the appropriate operating voltage required to provide sufficient luminance. Eesh. Timing characteristics. I do think that our VFD is probably being powered by the multiplex drive, or it's probably being driven by multiplex, given the controller that we're using. Because it's got multiple segment drivers. This is definitely not as many pins if you had a common lead for all of the segments for each tube. Yeah, so segment driver H corresponds to like this little side piece right here. I guess it helps if I make it large. Yeah, so this is describing the different drive modes of VFDs. I don't think ours is taking 10 to 15 volts. Probably taking more. I think the transformer is just not doing what it's supposed to be doing. And I think that our integrated circuit is doing multiplex drive based on the number of pins that we don't have. So we're only driving it with all these segment drivers, which is definitely not enough pins for eight tubes. If there's supposed to be a common lead for each anode, I guess. Okay. So I'm still not sure what the pinout for these is supposed to be. Of the actual things. Alright, well, we can try to figure out where the rest of these pins go. So we've got that one is right here. And this runs to this little thing. This green bar looking thing. And I think that's a capacitor. Ooh, there's a part number. Holy crap. Okay. I'm gonna look it up. Oh, is it a resistor? Oh, it looks like it's a bridge or bus resistor or something. Because it has, on the side, it's got printed, NI... Hold on. Oh, NTK 100K and then ohms. So it's a resistor. NTK 100K. Wait, is that what I said? Or did I say something else? NTK 100K ohms. Okay. Bro, I said giving me a bunch of freaking image searches now. What's wrong with you? Google. No, it's not a thermistor. I mean, it could be a thermistor, but I don't think it is. In TC. Oh my god, search is fucking awful, dude. Google search is awful. You suck. Like, I didn't say NTC. I said NTK. What is wrong with you? What is is there such thing as a bus resistor? What is this thing? Common pin on one side broken out through individual resistors to individual pins. Yeah, so why is it so fucking hard to search for a bus resistor like this on Google? I guess nobody would ever search that, right? NTK 220K ohm. Okay, so which side is the common, or which side is the ground on the resistor? I guess it's not ground, but common. Bus terminating resistor? What is this? Is this what I'm... No. Free! Resistor network? Oh my god. Y'all, it's called a resistor network. This thing. These things, they're called resistor networks. Now you can actually get accurate results from your web searches. It's beautiful. Look at it. Okay, so how do they work? No, I don't want to buy them. Alright, well, I guess I'll just look at the board. I'll look at the board and figure out which one is which. But I guess that answers my question of what the hell those things are. They're not capacitors, they're resistor networks. Wow. We're learning. Well, I am. Some of y'all may have known those already. Oh, it looks like it's this middle pin. Yeah, it looks like the middle pin. So this whole row of pins right here is this resistor network. Right here, this one. And you can see all these are going to, like, their own little place over here and over here, but this is the only one that kind of comes out and goes elsewhere. So this is going to be our common, I believe. We confirm that with this other one, this other resistor network, which is right here. This one's kind of the same. And then this is the output, or I guess input, I don't know, whichever way you want to see it. So I think that's how this works. We have our resistor network right here, and then we have a common coming out, going elsewhere. And this shit all goes somewhere else. So this is all going to, like, this, underneath this chip. Where it's going underneath the chip, I have no idea. Okay, answers that question. So now so this is a 100 kilo ohm resistor network. That's a 220. Which one is this? That's also a 220. I have no idea what this one is. Where does that go? This comes up over here. Comes down over here, right here. Into this thing. Oh my gosh. It's a good thing this is only like a 2-layer board. Yeah, I think I'm going to take some photos of this and start to, like, piece it all together in KiCad or something. And we'll figure out what's going on with it then. Good old flux. Yeah, I'm not too sure what these are. I think I want to do a little bit more research and try to figure out what the pins are on these before I start trying to throw voltage at them. Because I'm pretty sure that's a great way to burn something out. But yeah. I don't know, I think I made some good progress. How long have I been streaming? A few hours. Yeah, so I think I might call it quits here for the night. I might hop back on later, mess with some other stuff, but probably not. Probably on sometime this weekend though. I want to mess with this calculator a little bit more. But I'm gonna do a little bit more research about the VFD and how to actually like drive that. So, and then I can come back and throw some voltage at it and see what it does. Yeah. Thanks for hanging out. I hope you guys had a good time. If you want, you can check out the Discord. In the description, you'll find a link to the Discord. You can get updates when I start streaming, or I'll share like some photos of stupid stuff. But yep. All right. Hope you guys had fun. Bye.